Hey everyone, it's Kyle with Coding on Chain. And before we jump into any code, let me paint a scenario. Let's say you wanted to know any time that metadata or a newly minted asset was created, right? It's added to the chain. Sure, you can sit there and create a poll, right? Every few seconds, or let's say a minute, right? You just pull the database, if you're using Cardano DB Sync, and that's probably pretty efficient, right? But sometimes it's more efficient to be notified, to get a notification instead of having to pull. So what we're going to do today is something I've demonstrated through screenshots, thrown them on Twitter, whatever. But today I'm going to show you how to set it up. We're going to first set up a function and trigger in Postgres for our DB Sync database, right? I'm going to then show you, at least in the .NET, how to listen to a channel. And then we're going to use the new CardanoSharp DB Sync EF Core library. That is a part of my CardanoSharp proposal for Catalyst. And we're also going to use the Lift wallet. I don't know what number I'm on, doesn't matter, to send out the transactions with metadata and to mint those assets. All right, let's just jump in. It's going to be pretty fun. I really enjoy doing this type of stuff, and I'm happy I can finally show this to you using some really cool technology. All right, so the first thing we want to do is, we'll get to the code in a second. Let's go ahead and go to the database, and we're going to set up that function and trigger, and we'll walk through it a little bit. I'm not going to spend too much time on it. So real quick, I have two function slash trigger combinations here. So this is one, and we've got one right beneath it. So what are we really doing? We're creating or replacing a function. We give it a name. Ultimately, it's a notify, right? This is that whole listen and notify technique. So the first one is for transactional metadata. All right. So we create the transaction. What is it doing? We're doing a PG notify on a name that's the channel name, right? That's what we're going to listen to in our .NET application. What it's going to do is send a JSON object that has the operation, what the operation was. It's going to have a record key and the actual record itself. That's great. All right. So that's a function. The trigger, right? Again, we give it a name. This is, we just call it oh, never mind. This is the actual channel name. And what we're doing here is we're going to say after insert on public.tx metadata, which this is the Cardano DB sync table that holds all of the metadata. Anytime we get an insert, we're going to trigger and this function up above, which performs the notify. All right, that's great. I'm not going to go too much into this. I'm not a DB wizard, but I just know how to do this type of stuff. So what I'm going to do is I'm going to create this one. And you know what? I'm actually going to go ahead and create the bottom one. Ultimately, the function does exactly the same thing. It just has a different name. MATX mint. I'm not sure what MA stands for, but transactional mint. So this is the transaction in which we mint an asset with, token, whatever you want to call it. So great. So let's go ahead and get that one in there too. All right, great. So we got that all set up. All right, so the first thing we're going to do is send just a transaction, and we're going to listen for on that channel, which let's go ahead and grab that channel. So this is the TX metadata insert. That's what we're going to call it. I have set up a worker service. You can use, I'm sure, other technologies, but I want to demo some libraries, right? So I elected to use a background service. So this thing will just run. You could actually use a console app since we technically hold it right there. We just have a function that we declare that will take in all these notifications. So I'm not really going to explain the .NET side of things. I'm just going to set this up and we're going to walk through it and watch things get notified and see all the data coming in that gets posted from the Lyft wallet. So, all right. So the first thing we're going to do is set up the metadata insert. All right. Just to be specific, this is a little function, right, that will take in the information that gets posted since we are listening, right? So we have this .NET library that allows us to listen to a particular channel in Postgres. All right. So let's set it up. Just a note where we are actually using the CardanoSharp DB sync EF core library, right? This is part of it. So we have a context. This allows us to talk to the database. This has some connection information in all the models that are in the database. So what I'm going to do, since we know we're getting that TX metadata file, right, or record, we're going to go ahead and add a transaction metadata variable, and we will wait on the Cardano context. Let's see. We will. All right, we'll do it a little differently. Maybe a little fancier. All right. TX metadata, we're going to include, so just part in the .NET stuff. What I'm saying here is, okay, we know we're going to get the transactional metadata, but let's go ahead and join on the transaction table. So we're going to include that. We want to get, since we can't look it up directly, we're going to say where ID equals, and since, here, let me just do something real quick. So we're going to take this payload. This payload, remember, it's going to come in the form of operation and then a record. All right, so I have a little .NET object over here, Postgres record. All right, cool. We have the operation, we have the record. The record's really simple, but we're going to have to extract data out of it. And while what it sends to us is actually the whole record, I'm just going to grab the ID, use the EF core library to grab it from the database with some extra information. All right, so if I say payload, right, so that's the operation or the triggered payload, dot record. And I want to get that ID. Now I just know that there's ID there. Now, one thing to note is it's an object, so we have to convert this to a number. All right, like that. So what we're doing here is we're going to get a transaction metadata object that has the transaction record associated with it. That's great. Let's go ahead and print stuff to the screen to prove it, right? All right, so instead of me copying or just writing all this stuff, I already have the log messages. All right, so we're going to print out the key, and I called it something different. So we're going to print out the key, which is part of the metadata, and the JSON itself, and we'll print out the transactional hash. Cool. All right, so now the fun starts. So let's go ahead and start this. I'm going to put a breakpoint before we actually talk to the database on this one. Now, the funny thing is we may get somebody actually playing on the test net. So we are on the test net, and they may trigger this before I do. So let's hope that doesn't happen. All right, so just go ahead and do, well, don't need to do that. All right. So what we're gonna do is just send ourselves a transaction. Let's freeze. What wall is this? Okay. All right, let's look at the metadata before we actually post it. So we're gonna do this. It's a simple JSON object. All it says is Postgres as the key and triggered. And we're giving 777 as the key. So remember, we're going to print out the key, we're going to print out the JSON, and we're going to print out the transactional hash, whatever it is when it gets sent back to us. All right, so let's go ahead and attach trigger. Yep, and send that. Now we get to wait. What did I do wrong? Blah, blah, blah. All right, I'm not sure what I did wrong. So we will use a different wallet. So yeah, just pardon this. Very much a work in progress wallet. What is the password? Triggered. Yep. Okay, cool. There might be something wrong with that wallet. That's okay. So our transaction hash is B0BC and then 61C1. All right, so ultimately we are waiting for the blockchain to accept our transaction, throw it in the chain, and then the DB sync will pick it up and throw it in the database. So we're kind of waiting for a little bit to happen here. And a good note to whether, like, when that might happen is just kind of watching the wallet for it to get picked up. Okay, cool. So there it is. Let's see. Let's just look at the payload real quick, just to see what it looks like. And um, okay, so here's that operation, right? And the record, and here is that record object. Now so here's our JSON, right? Postgres triggered. There it is. There's our key. But that's great. Let's use the CardanoSharp library to grab some structured objects. Grab the transaction object, and let's actually print some cool stuff to the screen. All right, so you know what? I'm not going to dig into the object. I'm just going to let it prove it right here. All right, so let's see. Okay, there we go. So the metadata key is 777, metadata JSON, Postgres triggered, and transaction hash, that B0BC61C1. We can compare that right here. There it is. Just to, there's the JSON. Cool. All right, so let's do something a little more, um, I don't know, it's kind of proving the point just even more so, right? So what I'm going to do is stop this, and we're going to use the minted trigger now. And the mint trigger, what I'm going to do is I'm going to post JSON metadata with the mint, and we're going to use the CardanoSharp library to go even further into the database, not just get the newly minted asset, but get the metadata that's associated to the minting transaction of that asset. So this should be pretty fun. All right, let's go ahead and chop that off. We don't need it. All right, so let's go to Postgres, right? We got the MATX mint insert. This is the channel we need to listen on. So let's go ahead and insert that there. And all right, so now let's get the object from the database. So let's see, bar, and we'll call it, what is it, MATX mint? Yeah, sure, we'll call it that. Then wait on the Cardano context. All right, so let's go MA, sure. Includes, we want to tell it, hey, don't just include the one record by the ID that we're going to get, but I want you to start joining other tables so we can get other information. TX, right? Because it is minted via a transaction. So we know we'll have the transaction, and we know that transactions have metadata. So note that is a collection of, or an array of metadata records. It doesn't have to be one JSON, right? So I can add multiple keys, which we're going to do that. So I want to show that we can actually show all the metadata that gets. All right, what do I want? I want ID equals, and it's the same thing as before. So we want to convert this to an int, and it is payload.record ID once again. All right, cool. And we will log information. What do we want to output? We're going to output the name. So asset name. Let's see. So that is going to be matx mint.name. All right. So the thing about name is name comes in a byte array. It doesn't actually get stored as a string, or at least Cardano, or at least EF Core doesn't interpret it that way. Even though, and let's look at that table real quick. So public MATX mint. So we can see that the first token minted on the test net was Nutcoin, then LQ, a blank coin, I don't know. We got some blue cheese, and a bunch of others, right? So you can see we've all been playing around. How many? Let's see. How many? Count. Let's see how many tokens were minted on the testnet so far. Almost 1,500 tokens. That's pretty cool. Okay. But yeah, just to prove point, we did see strings, right? Like we saw, we could read them. You know, name. It's in string format, so I'm not really sure why it comes back as a byte array, but it does. So we're not going to do that. What we're going to do is call it an asset name. I mean, everyone calls these tokens, but I'm saying asset because they're referenced as, right, um, a native asset, right? That's what we call them. All right. So ultimately, we just need to convert it to a string, which luckily we can do that pretty simply with this name. All right. So we're going to print that out. The other thing we're going to print out is the quantity. See how many we minted, right? All right. So the other thing we're going to do, right? We said we're going to attach metadata to this. Now we know that, you know, the mint record is attached to one transaction, but a transaction can have multiple metadata JSON values associated with the transaction. So let's we're going to loop through it. So real quick, I'm going to show you what the JSON is so you understand a little bit. These are the two JSON transaction metadata records that get created. So it doesn't store this whole thing. What it does is it stores each key. So each key will have a record. So our transaction will have two transaction metadata records in the database. We're saying source, we're minting it from the Lyft wallet, and we're saying we're capturing it by .NET Postgres listen notify mechanic, right? All right. So let's make sure we can log that out. So MATX, we want to make sure that the transaction, let's see, metadata. I will say any. So let's see if we have any. And for each metadata in this, and I need to do this. So we want to say metadata key and metadata JSON. All right, so the MD key, yep, and MD JSON. What else can we throw out? Oh, you know what? We have the transaction, right? So let's go ahead and say tx hash. I think, okay, tx hash. Okay, I have this little extension method get hash, or sorry, this is from the previous trigger. Get hex, sorry, get hex. So it's a hexadecimal that it gets whatever. It's a conversion that we can do pretty simply in .NET that I have a extension in the CardanoSharp library that we can just tack on there and get a nice, get the hash that we're typically used to seeing. Okay. So just to review, we're going to print out the asset name, quantity, the transaction hash, and any metadata information that gets associated with the minting of this asset. Okay, I'm going to put a breakpoint in the same place that we did before. Go ahead and boot this up. Okay, that's running. Let's that. Where is the Lyft wallet? Right here. Sorry. Okay. So we need a mint. Should we mint? You know what? We need to mint the CardanoSharp token, right? And there's only gonna be one of them. All right, and let's go ahead and put mint on there. Open and mint it. And of course, oh wait, do I need to use a different? Oh, I need to use a different wallet. So close. A lot of progress, a lot of work, but basically the Lift wallet sometimes is a little buggy in the build modes. All right, cool. So there we go. So that's our transaction hash. So this is what we're looking for. Oh man, that was quick. All right. Unless somebody else is minting something. Let's see. Hard to tell. Let's just so yeah, so real quick to all right, so we can look at the record. See, I can't read this. Now it's pretty close. Like we did mint one, so this might be us. Let's find out. So I'm just gonna go to a breakpoint here and let it run. All right, so it should be printed out now. And we'll go ahead and put this up. Roll up. All right, CardanoSharp. That's our asset name. We minted one. There's our transaction hash. Does it match? 3FAF. Yep. 40C0. Yep. And here's our metadata that was associated with this minting transaction. So 778 source lift wallet 779 captured by .NET and Postgres listen notify. Okay, so there it is. I have a Cardano DB sync setup on the test net that's listening to the blockchain and populating a database. I set up a function and trigger that allows me to capture any newly added metadata or any newly minted assets. It sends out a notification. So I set up a .NET application that is listening on those channels. It uses the CardanoSharp EF Core library to then communicate back to the database and get more information about what was just told about us, and printed it out. So there it is. I mean, this is awesome. I hope you guys enjoyed this. Let me know if there's any other type of cool things that we can explore. I love going down the rabbit hole like this and trying out different things. Anyway, thanks for watching.